Hello everyone. So today we are going to see the Leetcode POD, and the problem statement is magnetic force between two balls. So the problem statement here given is that in the universe Earth C137, Rick discovered a special form of magnetic force between two balls if they are put in his new invented basket. Rick has n empty baskets. The ith basket is at position I, and Morty has m balls and needs to distribute all the balls into the basket such that the minimum magnetic force between all any two balls is maximum. Rick started the magnetic force between two different balls at position x and y, and that is the absolute difference between x and y. Given the integer array position and integer m, and we have to get the maximum magnetic force we will try to maximize the minimum magnetic force. So here we can see it is given an example here, and in this position 1, 2, 3, 4, and 7 there are baskets, and we have to put three balls, choosing any basket out of these, and we have to choose such that the minimum force between any two baskets, means any two balls, should be maximized. So if, let's suppose, if we are choosing basket 1 and put one ball here, and basket 3, then the difference between these two baskets is 2, and here the minimum force will be 2. And if, let's suppose, we are putting another ball at 7, then another difference between the balls will be 3 and 7, so 4. So difference between these will be like 2 and 4, so minimum we have to choose out of that. So now the difference will be so answer will be 2, but we have to maximize it. So we have to put the balls such that the difference between any two balls is maximized. And similarly we will try it for the other test cases as well. And constraints given are here: n is equal to position length, and this can vary from 2 to 10 to the power 5, and position I value will vary from 1 to 10 to the power 9, and all positions are the integers inside the position are distinct. No two baskets are present at the same position. And yeah, we the m value, means number of balls, can vary from 2 to length of position. So this was the problem statement all over. So let's start the coding part. So yeah, firstly we are going to take the position length is equal to n, and here we can see like we have to try with the position value. So we will firstly sort it out, and yeah, most importantly, this problem is also belongs to binary search on answer type category. Here we have to choose the lower pointer and the higher pointer from which we will search for the answer, means the maximum value, which is minimum for the magnetic force. So we will firstly sort it out. Here the lower value, which is magnetic force, can be 1, because if we are putting, let's suppose, two balls just adjacently, then the minimum difference will be 1. But if we want to maximize it, then it will vary from the position of the first basket in present in the position, and the last basket present in the uh, in the sorted position array. So here now we are going to apply binary search. Certainly the answer, firstly it should be minimized, because we have to get the maximum required value, required force between any two balls. And yeah, so let's, here also we are going to check if it is possible or not. If we are getting is possible as true, then we are going to save the answer as mid, and we are going to maximize the value. So lower point will be mid plus 1. Otherwise we are going to minimize the pointer, and the high value will be mid minus 1. And after that we are going to return the answer. Okay, so now we are going to see the is possible function. So it is going to return the boolean value, and it is going to take parameters as int of gap, int the number of balls, and int position. So we are going to keep one variable called ball count, which is going to keep track of the number of ball we are going to make with this number of gaps. So it will be initially 1, and yeah, obviously we are going to keep track of last position where we have kept the ball. So it is initialized with position 0, and we are going to traverse in uh, the position anywhere whenever we are going to get that position of I is greater than or equal to gap plus the last position, then we are going to make the last position as position of I, and we are going to increment the ball count by 1. So now we are going to return that if the ball count is greater than or equal to number of balls, then it will return true, otherwise it will return false. So let's run it. It got accepted for these given test cases. Now submit it if it gets accepted or not. Okay, it got accepted, and it is beating 94% of the total accepted solutions. So let's analyze the time complexity and the space complexity of this problem. So here we have used arrays dot sort, which takes big O of n log n time complexity, using this while loop, and every time this is possible function is taking big O of n time complexity, while this while loop is taking log of max and multiplied by n. So total time complexity will be big O of n log max, where max is equal to the last position minus the zeroth position. And yeah, this was the time complexity. When we are talking about the space complexity is big O of 1, because it is not taking any extra data structure to store the values anywhere. We are just using normal variables. So this was about the solutions analysis. Thank you.